Okay, good evening, Professor David J. De Los Reyes. Okay, my topic for this session will be ellipse and its relation to circle. It's a little bit quite interesting because not all of us know that the emanation or where circle came from, it is actually from ellipse. So for tonight, I will be discussing that circle actually emanates from, no, circle actually emanates from, circle emanates from ellipse. Sorry for that one. Okay, let's proceed. So our topic will be ellipse and circle, meaning the relation of ellipse and circle. This will be analytic geometry. For an ellipse, the area is actually pi AB. Pi AB, where A is the major axis and B is the minor axis. So for us to get the area will be the product of pi times the length of the major axis times the length of the minor axis. Actually, that is from analytic geometry. But this was actually derived from integral calculus. All the equations we are using under analytic geometry was actually derived from integral calculus. But since we are on the topic analytic geometry, I will just give you the formula on how to take the area of an ellipse. And the area of an ellipse is actually represented by the equation pi multiplied by the length of the major axis times the length of the minor axis. And also under analytic geometry, the equation of an ellipse with center at the origin is represented by x squared over a squared plus y squared over b squared, and this should be equal to 1. So by knowing these two relations here, okay, or two formulas, we could now derive the formula for the area of a circle and the equation of a circle. That's why I told you a while ago that a circle emanates or came from ellipse. Okay, we shall now consider the figure to be a circle. Circle meaning this should be the x and y axis. We rotate it like that. So the distances are actually equidistant from the so-called origin. And that equal distance is actually represented by the radius of the circle. Okay? So to derive now the area of a circle using the conditions for an ellipse, we will start with the area equal to pi AB, right? But for a circle, the distance from the origin, from all the points with respect to the y and x axis are all equal. So I place it here, A is equal to R, B is equal to R. So meaning for a circle, this was actually A for an ellipse, right? But for a circle, that is equal to R. And this length here is actually B. But for a circle, that is also equivalent to R. Okay? So for a circle, the length of the major axis and the minor axis is actually equal to R. So A here is equal to R and B is equal to R. So with these known conditions, and we will be using the equation for the ellipse, area now for a circle will be pi times A, which is R, times B, which is also R. So area now of a circle is actually pi R squared. Okay? So the formula that we are using, okay, even under geometry, area of a circle is pi R squared. That formula emanates from the equation of an ellipse. Okay? So actually we have compressed one complicated problem here. If we are given a problem in a circle, just think that the two are interrelated. Okay? So the area of a circle is pi r square, and this was derived by using the area of an ellipse. Okay? For the equation of the circle, actually it also emanates or came from the equation of an ellipse. If for the equation of an ellipse is actually x square over a square plus y square over b square is equal to 1. When a is equal to b equal to r, we place this condition here, back here. What will come out? X square over a, but a is equal to r, so this will be, instead of a square, this will be r square, right? Plus y square over b, but b is also equal to r. So this will be b quantity square or simply r square. And the right hand side is actually 1. And to bring out the equation of the circle now, we will multiply all the terms by r square. Right? So for the left hand side, this r square cancel with this one cancel with this. So what remains on the left will be an x square plus y square. For the right hand side, it will be 1 times r square, or this will be equal to r square. And this equation is actually the equation of a circle with center at 0, 0. It is this one. Okay? So you notice it? This is the equation of the ellipse, a center at 0, 0. And this is the equation of a circle with center at 0, 0. But this equation here emanates from this. That is when the condition A is equal to B equal to R. Oh, I think that is an interesting topic. Okay? So I will repeat it for the last time before we will go tonight. The area for an ellipse is pi AB. The equation is x square over a square plus y square over b square equal to 1. That is an equation of an ellipse with center at 0, 0. And for a circle, the area will be equal to pi r square, and this equation emanates from this. For the equation of the circle, again, by using this equation, after the simplification, what comes out is x square plus y square equal to r square. That's an equation of the circle. Okay, good evening from Los Angeles.